Okay, this one is about terminal velocity. Terminal means end, velocity, speed in a given direction. So this is like a top speed something can go. So you often get taught it in terms of parachutists, skydivers, that sort of thing. But it can happen with cars, bikes, planes. It's their top final speed. It's to do with forces, and here we've got two people who have jumped out of planes. Now, I don't know anything about skydiving and parachuting, so I'm going to use the wrong terms, but we'll try. So here, these two people have jumped out of planes, that's right. And they both have a weight, remember it's weight because it's in newtons, of 700 newtons. So this weight of 700 newtons is bringing them down to Earth. Now this jobby here, this bloke here, as he jumps out of the plane, the air rushes up and bumps into him. That's what we call air resistance. Okay, so that air resistance, come on arrow, come on, don't do that, come on arrow, yeah, right, so that air resistance here, we can use a force arrow there. So we'll say that the air resistance on this one is about 40 newtons, let us presume. Because if we look at this force diagram, because there's 700 newtons up there and 40 down here, we have a resultant force of 660 newtons downwards. So he's rushing downwards. And because he's going downwards with this resultant force, he's speeding up, he's accelerating. And as he accelerates, okay, gradually the amount of air hitting him here, so the amount of force that air is hitting him, balances out and actually ends up at 700 newtons. So he accelerates and accelerates and accelerates, more and more air particles hitting him, so the force of the air resistance increases until eventually the forces are balanced. Now when the forces are balanced, if you looked at the balanced forces video, you know there's no resultant force. But because he's already moving, he's now reached a constant speed. That's his terminal velocity, his top speed, where the air resistance and his weight have balanced out. It's taken quite some time to do that. With this one, let's say that he's jumped out of the plane with this open. He wouldn't, I'm sure. But let's say he has. The same air here is hitting the parachute and him, so a lot of air resistance straight away. So straight away we've got huge amounts of air hitting him and the parachute, so that at the beginning you might have a air resistance of 600 newtons right at the start, and it doesn't take long to balance out. So therefore, if it hasn't taken long, he hasn't had much time to speed up or accelerate. So this one will have a much lower terminal velocity than this one. Okay, let's just do that again. So they both have the same weight. The air hitting this one is much lower to start with because there's not much area here for the air particles to hit it. So he speeds up, he's got time, he's speed up, accelerate until eventually there's enough air resistance, enough air is hitting him to balance out those forces. And once those forces are balanced, he's reached his top speed. It takes quite a while for those forces to balance out. So he has a lot of time to pick up massive amounts of speed. This one, however, has jumped out the plane already with this parachute, and the air there's loads of air resistance because there's a lot of area for the air to hit. So maybe, we're just making it up, that it's 600 newtons of air resistance automatically when he jumps at the plane. And as he speeds up, okay, because you're bound to, as you jump at the plane, you speed up, more air hits it until the air reaches 700 newtons, the same as that one. So the air resistance reaches 700 newtons, balancing out his weight. And at that point, he's reached his terminal velocity. It didn't take long, it was very quick because it already started at 600, so he hasn't had much time to accelerate. Therefore, his terminal velocity is much lower than this one's. Thank you.